Hello, welcome to the Majestic Devlog. The Majestic is a casual, open-world exploration game. In the last few weeks, I've begun work on game objectives, character abilities, and story delivery mechanisms, and I continue to build out the level. First, I'll discuss some of the work I've done with objectives. The first objective is the most basic. It's the primary resource and currency. It's depicted as a magical glowing orb that appears over the landscape. I call it Essence. Simply flying through it will collect it. Essence is meant to be abundant and easy to acquire. It's the thing your character continually wants to collect. This objective will undoubtedly be changed a lot throughout development. What I like right now is how it looks in the level. Seeing the glowing orbs across the landscape adds a nice magical element to the game. In the future, I plan to overhaul the particle effects. Maybe have more of a color gradient and adjust the brightness of them. It's a bit blinding as you approach them. It's a basic objective, only a collider for collecting them. To spawn them, there is a manager actor that handles when, where, and how many of them to spawn. The Essence Manager tries to spawn Essence every 5 seconds. It also checks the distance of existing Essence and destroys any that are too far from the character. Right now, 15 Essence can exist at a time. There are several reasons for capping this. The primary gameplay reason is to keep the player's attention focused. Also, visually, too many start to look cluttered, which distracts from other visuals in the level. And lastly, there are performance concerns if too many were to exist at once. Essence are randomly spawned in a 2,000 meter radius around the player character. They also randomly spawn from 5 meters above the ground to up to 450 meters above the ground. They are an infinite resource. They will always be available to collect. However, there will be a limit to the number the player can have stored. I've also started working on some major objectives. Objectives that are more puzzle and story driven. I'm using data assets to help streamline the creation of these. Basically, a data asset handles all of the unique properties of the objective, such as the mesh, material, descriptions, and parameters. Then you have an actor that reads the data asset and handles the actual logic for the type of objective that it is. So here is a pickup actor that is fed a data asset. In the constructor, it sets the mesh and material per the information from the data asset. For initial testing and implementation, I created this gem asset. It uses the pickup actor as a base class. I can easily create multiple variations of this gem by duplicating the data asset and changing the parameters. For example, with different material instances, I can quickly set up gems with different colors and descriptions to match. I can also add logic specifically to this gem. Here I have a timeline that adds rotation and a bobbing effect. And I added some more visual elements such as god rays and particle effects. I still need to build out the logic when interacting with these, but that will be easily accomplished within the parent actor. Unlike Essence, major objectives will be hand-placed throughout the level and will contribute toward overall gameplay progress. Even with plans to have some collectible items, I'm not planning on having an inventory that the player can manage. So that's some of the work done on objectives. I have also done the initial implementation of the ability system. In the past, I figured using the gameplay ability system was overkill for a game like this, but I've decided to reverse that thought. That said, I'm now taking advantage of the gameplay ability system. This is a plugin that was initially developed for Paragon and then was used in Fortnite. The system is extremely powerful and handles much more than just abilities. It also contains all of the functionality for character attributes and effects. Implementing this system took about 3 to 4 hours one evening. I just followed one of the numerous tutorials online, which tend to mirror the action RPG example game from Epic. The first ability is what I call the dart ability. This is where the character darts forward very quickly for about 1.5 seconds. I already had this working without the ability system. I simply had to copy and paste the code into a gameplay ability blueprint and add a cooldown effect. The ability is free to use, which is likely to remain, but I'll probably add a limit to the number of uses within a period of time. So, when the ability is used, it commits the cooldown, plays an animation, sets your maximum fly speed to about 100 meters per second, and after 1.5 seconds it sets your fly speed back to default and ends the ability. Now, to do this properly, I still need to remove the delay node and add an effect with a duration that handles that part of the ability. Again, this is basically how it was set up in the character blueprint before. Here's the ability system component which is attached to the character. The system supports attribute sets. Right now I've set up health and essence as 2 different attributes. Within the character blueprint, I can easily attach passive and active abilities to the character. Implementation is almost entirely done in C++, but afterwards nearly everything can be done in the editor. Here I have a gameplay effect. Gameplay effects are perhaps the most powerful part of this plugin. This effect controls essence acquisition. It happens instantaneously and simply adds 1 to my essence attribute. It's not attached to any ability. Instead, this effect is activated when the character triggers the Essence Collider. This effect is the cooldown for the Dart ability. Right now, the cooldown is set to 2.5 seconds. I have it granting a tag to the character for the duration of this cooldown. Tags are super useful. I can control what effects and abilities are activatable while a tag exists or doesn't exist on the character. Here's the event that triggers the acquisition of essence. As you fly through essence, it fires this event on the character, which increases the essence you have stored, and it also updates the HUD with your current essence total. I quickly put this widget together to display the essence total. I stay away from binding variables. Instead, I update all HUD elements with events. There's no reason to check totals every frame with something like this. Also, it might not be very noticeable, but I have an animation that plays whenever the essence total changes. So that's the start of working with the ability system. At some point I need to set this up for AI and create some form of combat. This is a casual game, so it's not going to be very skill testing, but there will be evil entities you are meant to destroy. Also, I may bring back the Wisp ability from my last game as another core ability that can be used often. So, I had a week where I was just not feeling well, so instead of programming, I decided to do more level updates. This type of thing is more chill, just copy and paste a lot. I imported this canyon asset from Quixel and started working on these canyons that I had previously blocked out. I also have these floating islands. The canyons and the islands give the level a lot more verticality, perfect for a flying exploration game. Here's a nanite view. Basically everything except the landscape and foliage is made with nanite meshes. For the trees overlapping the canyon rock, I can get them out of the rock easily by deleting and regenerating the procedural foliage volume. For now I'm just quickly blocking everything in. I'll continue to enhance the level anytime I need a break from programming. Now for the story implementation. Here's a sequence I started creating to help test story delivery. It's half cutscene, then halfway through you get control of your character and can watch it play out however you see fit. These story pieces are really the main part of the game. It is a story game after all. I also spent a lot of time setting up a subtitle system. When creating my last game, adding subtitles took me a lot of time to implement. The reason is because I want the subtitles timed out to follow the voiceover, similar to how television and movies do it. Because I have this niche requirement, I've not found a great way of accomplishing this for games. So, how I did it before was I loaded the entire script into a data table. Every long pause by the voice actor was an individual row in the data table. There were over 1,000 rows. Localization was a bit of a nightmare because translators didn't have full context of the dialogue. They had to refer to the script constantly and often still had questions. Using a data table also meant that the entire script was always loaded into memory. For this game, I wanted to try tackling this a different way. I also wanted to see if I could utilize dialogue waves, a type of asset in Unreal that handles voiceover by designating a speaker and a listener, and even handles subtitles in a rudimentary way. The main point of dialogue waves is to have different voiceovers for similar lines of text. For example, a greeting by a merchant in an RPG can have different inflections based on who that merchant is speaking to, but the words themselves don't change. I may use this level of flexibility in some cases, but largely I will have just one context. Here I have a character named Daisy as a speaker, and she's speaking to herself. I haven't started dealing with voiceover yet, but for this test I'll just add some test dialogue in the text field. I have a voiceover actor that handles the processing of the voiceover and the subtitle. From the dialogue wave, this actor will play the wave file and it will send the speaker and spoken text to the subtitle container widget. This voiceover actor will exist in the level and can be added to the level sequence. I then create an event where this dialogue will be played. I set up the event with the context. I added a play rate variable to help control timing of the subtitles, depending on if the voiceover actor is speaking fast or slow. My subtitle container widget processes the spoken text. It splits up the string based on the punctuation found within. It then creates an array of strings that get sent as individual subtitles, with a delay based on the type of punctuation and the number of characters in the string. I've set each type of punctuation that gets parsed as a localized text field. This way, I can control how the string is parsed in any other language as well. Here's an example of how the text is parsed. Now, if I add more text mimicking how the script is written with expressions and beats, this example would have been 7 or more rows in my data table method. Now it's all packaged nicely in one line and has full context when localizing. Here's how that looks. It might be a small thing, but story delivery is extremely important to me, and it's also something that took a ton of time to implement in my last game. I feel this delivery for subtitles is in a decent spot barring some visual adjustments. The true test will come once I try to marry it up with the actual voiceover. And even with all this work, I do intend to allow the player to turn off subtitles completely. That's going to be it here. Please wishlist and subscribe, and I'll see you in the next one.